Guess who's back? It's another math episode from Mr. Matt. Alright. So in today's lesson, we'll be doing test 1 test. We're going to start this off by rounding decimals. Question number 1. Round 25.64198 to the nearest thousandth. So the first question I normally like to ask myself is, let me look at that number 1000. Alright, and I like to personally say, like, how many zeros are in that number 1000? So when I take a look, we have a total of 1, 2, 3, and that lets me know that I'm going to be dealing with the third digit to the right of my decimal. Alright, so it's going to technically be that number 1. And I'm going to just put a little line right here, and I like to stop it. Okay, and if you take a look down here, I put a little visual just to remind you. We have our 10,000ths place, thousandths place, our hundredths place, then our tenths place, decimal point, and we have our ones, our tens, our hundreds, and our thousands. Alright, so now we're dealing with the thousandths place. The only number that can possibly change that 1 is the number to the right of it. Alright, now what we like to remember, if that number is 5 or above, we'll give that 1 a shove. If that number 9 will be 0 or below, we let it go. Alright, in this scenario, 9 is greater than 5, so we're going to end up actually rounding our answer, and our final answer becomes 25.642. In question 2, we're going to be rounding 0.0432 to the nearest hundredth. So I asked myself, alright, how many zeros are in that number 100? A total of 2. So I want to look at 2 values past my decimal to the right, and only that number in the thousands place can dictate whether we're going to either bring our 4 up to a 5 or leave it alone. And remember, if you ever forget, if it's 5 or above, you give the 4 a shove. If it's 0 below, you just let it go. Everything after our line. So since it's a 3, we end up just letting everything go after the 4. And our final answer is 0.04. Question 3. Round 1.68714 to the nearest tenth. When you think about that number 10, it has 1 0, so we're focusing on that first digit to the right of our decimal place, and the only number that would allow us to round up will be the value after. If that 8 is 5 or above, we'll give the 6 a shove, but if that 8 is 4 or below, we just let all those numbers go after our line. Since the 8 is 5 or above, our final answer will be 1.7. Now let's move on. In question 4, we're going to order the following integers from least to greatest. Let's start with letter A. I'm first going to order the numbers, but when I order these numbers, it's most important to line up the decimals. Once we line up our decimals, we can actually compare their place values. Let's take a look. Now that our numbers are lined up, what we like to do is just make sure each number goes to the same exact place value after our decimal. As you can see, the number that has the most amount of values after our decimal is our first and third value. They have a total of 4 numbers after our decimal. So the goal is just to make sure each of the other values, the other 2, have the same amount of values after our decimal. Let's take a look. Now that this is done, I wanted to see to it that I have 2 zeros added to my last number, 1 0 added to my second number, just so I can make sure all of my values go to our 10,000ths place. Now we can begin trying to order them from least to greatest. I like to look at each individual column at a time. So let's look at our first column. Each value has a 1 in the first column. They're all the same. They all compare to one another. So we can now move on to the next column. Verify just like in Instagram. In our second column, each one has a 0. They're all the same. They all compare to each other. So now we can move on. But now when I get to our third column in the hundredths place, the number that's the greatest is the value 2. So what I can do, since I see this is our greatest value and our goal is to go from least to greatest, I can actually end up working backwards. So I'm going to put the number 4 right here just to indicate that this is going to be our greatest value. And now I'm going to continue working backwards. Now that that's done, I only need to really focus on the last 3 digits of the remaining numbers. It's like looking at, I have 190, 196, and 198. If I'm working backwards, the closest number to 200 would be 198. So I'll put a 3 right here, meaning that's our third place. I'd put a 2 right here for 196 because that's still closer. And then the least would be this value right here. And once you're all done, you just arrange these all in order. Let's take a look. And here is our final answer. And now on to question letter B. We're going to go ahead and do the same exact thing. We want to order our values from least to greatest, but most importantly, please make sure you line up your decimals first. Once your values have their decimals lined up, now we can look at the values after our decimal. As I look at all 5 numbers, the farthest number extends to the thousands place. So I want to make sure all of my numbers extend to our thousands place by annexing zeros. So let's take a look. Now that all of our values extend to our thousands place, we can then move on to comparing our columns. And remember, our key goal is to go from least to greatest. So let's start off with the first column. So in our first column, as I can see, I have a 3, 3, 3, 3, and then a 0. Zeros are a number that's the least, so I'm going to put a 1 right next to this one. Alright, as for the remaining values, they all begin with a 3. So all I'm really focused on is now all the values after the tens place. Alright, and I'm going to underline each. Alright, and if we're going from least to greatest, we can look at these numbers like 18, 180, 100, and then 80. Alright, so if I'm ordering these values from least to greatest, I know the next number should definitely be 3.018. Alright, that's like looking at the number 18. And then we get a little bit bigger, we have the 80, 3.080. The 100, and then the 180. And now lastly, we line up our values to get our final result. And here's our final result, listed from least to greatest. Now on to question number 5. So in question number 5, we want to compare the following numbers using our greater than, less than, or equal to. Alright, so inequalities are going to be used to compare for letters A, B, and C. We want to start this very similar to how we did question 4. We line up our decimals and we compare each column so we can figure out who will be the greater value so we can point our inequality that direction, unless we have a quantity that is equal. Let's take a look at letter A. So after you line up your decimals, you want to make sure that each is going to extend to the thousands place. At the moment, our second number extend only to the hundredths place, so I'll just add a 0 so they both can go to our thousands place. Now this is where we can start to compare our columns. Column 1 has a 0 and a 0, they're both the same. Column 2 in the tens place, both contain a 4. But once you get to column 3, you realize that your number on the bottom has a greater value, meaning that 0.45 is greater than 0.435 because our value in the hundredths place has a 5, which is greater than the 3 in our hundredths place for our first number. On to letter B. We have 2.001 in comparison to 2.0001. First, want to make sure both values extend to our 10,000ths place, so let's go ahead and do so. Now that this is done, we want to compare each column. So we have a 2 and a 2 in our ones place, a 0 and a 0 is equivalent, a 0 and a 0 is equivalent. But once we get to that thousands place, we realize that we have a 1 here. And that 1 is greater than this 0 in the thousands place. So that makes 2.001 greater than 2.0001. Now on to letter C. In letter C, we have our 4.089 in comparison to our 4.0890. Our second value extends to the 10,000ths place, so I want to make sure that's happening in my first number. Now that they're there, we're going to go ahead and compare each place value. We have a 4 and a 4 in the ones place, that's equal. 0 and a 0 tenths, 8 and 8 in the hundredths, a 9 and a 9 in the thousands, and a 0 and a 0 in the 10,000ths. Whenever you check out each column is the same, then we have an equivalent. So that's it for this part.